Hi all, this is Professor Sarvanan from Mechanical Engineering Department. Today in the second year Mechanical Engineering subject Applied Thermodynamics, we are going to see one practical, that is variable load test on diesel engine to determine various efficiencies and to plot the heat balance sheet. Now this performance is done on a single cylinder diesel engine. So now the various efficiencies under which to find out those efficiencies, initially we need to calculate the brake power. We all know what is brake power already. So here the brake power calculation we are seeing. For that the formula is 2 pi nt upon 60, where n is the speed of the engine and t the torque which is being measured in the setup. That we will be seeing shortly. What is that? Then we also will be looking into that, calculating the specific fuel consumption. So how to calculate the specific fuel consumption? Here, that is SFC, also called as the SFC, fuel consumption per unit time upon the power, which is the specific fuel consumption, which we can calculate. Then frictional power. Frictional power, we also know that is the different power losses which are happening inside the engine, due to which the efficiency of the engine comes down. So here we are the diesel, since the diesel engine, we are calculating the friction power using Williams line method by plotting a graph between the fuel consumption versus the brake power. So we will be calculating the friction power. Once if we get the friction power, we already calculated the brake power and we have calculated now using the graph frictional power. So we can calculate the indicated power IT. So indicated power is the, we have already, that is the power generated within the combustion chamber. That is the total power. Now indicated power is IP is equal to XP plus BP, that is the brake power. So we get the IP. Then other efficiencies which we are going to calculate are brake thermal efficiency, that is the brake power upon MF into CV. MF where MF is the fuel consumption, that is kilogram per second, and CV is the calorific value of the fuel, which is kilojoule per kilogram, the unit. Then we have the indicated thermal efficiency, where in the replacement of BP we are having the IP. IP upon MF into CV. We have already calculated the IP here. We are going to substitute the value here, and MF mass of the, that is the fuel consumption, and CV also calorific value of the fuel. So with that help, indicated thermal efficiency is calculated, and the volumetric efficiency. Here the actual volume of the air injected upon the swept volume in regarding to the cylinder swept volume, that we will be calculating. So with this help of formula, V actual upon V swept. Yeah, these are the things which we will be calculating for the case of different efficiencies under the SFC. Now we are going to see the heat balance sheet. In the heat balance sheet, which we have just told, the second part of the experiment which are given here, see in the table, we know what is the heat balance sheet. That is the how much heat is given as the input and how the heat is spent in different ways. So that is this table indicates. If we see the heat supplied by the fuel, that is the QS, is the mass of the fuel, that is the fuel consumption multiplied by the calorific value of the fuel. So whatever we are getting, that will be in the kilojoule per minute. And that is considered as a 100%, because this is the heat input is given. Now we are going to see how this heat is in various way utilized or spent. So that is given the other part of the table, that is heat expenditure. A partial amount of the heat is converted into useful work. What is the useful work? That is the brake power. So that is the Q1. Brake power, we have seen the formula for that already, how to calculate the brake power. BP is equal to 2 pi nt upon 60. That is, we can calculate. So the value we will be putting here, and how much percentage of that from the overall percentage. So that we will be putting here, share of the brake power. Then second is the heat carried away by the engine coolant. cooling water. So in the engine, the engine need to be cooled. For that, the water is utilized. So how much heat is carried away by that? That will be calculated using this formula, mW is Pw into T2 minus T1. This T2, T1, this detail, we are going to see what is this in the experimental setup with the written details. So that we are getting. This mW is the mass of water, fluid of water being utilized for this. Then third part is this is the Q2, and third one, heat carried away by exhaust gas, because we all know the exhaust gas which is very hot. So obviously a certain amount of heat is being taken by the exhaust gases. So that will be calculated using the formula mgCpg into T5 minus T6. This is the here. Then the final is the unaccounted heat loss. That is the unaccounted means which will be through the heat transfer to the surroundings and other things. So which are coming under unaccounted heat loss. So we will be calculating that using Qs, which is Qs is the heat supply minus Q1 plus Q2 plus Q3, where Q1 is the brake power, Q2 is the heat converter into carried away by the cooling water, and Q3 is the heat carried away by the exhaust gases. So and we will be equating that. So final it will be the percentage will be total summation will be 100%. So that is how we are balancing the heat sheet. Now we are going to see the remaining details in the experimental setup. The experimental setup for the single cylinder diesel engine which we are having here. So this is the engine setup for the single cylinder diesel engine, and here we are having the control panel for the same engine setup. In the engine setup which we are having here, this is a single cylinder diesel engine, that single cylinder diesel engine which we can see here, and this is a fuel injector, this one. The cooling water inlet for the engine is here, which is mentioned, and the cooling water outlet from the engine which is coming out here. This is the intake gas air inlet, this one, and this is the exhaust gas outlet. Here we have the flywheel, and this is the eddy current dynamometer. This is used for measuring the load or torque. This is the control panel for the single cylinder diesel engine, and here we can see the details how to take the readings for the different parameters. The different parameters which we are going to measure are speed of the engine, which will be measured through this digital meter, and here we are having the load indicator through which we will be measuring how much load will be applied on the engine. Then also we will be having using this panel we can measure the different temperatures for the different conditions. So here the temperatures are mentioned. T1, that is the engine water inlet, engine water outlet T2, T3 is the calorimeter water inlet, T4 calorimeter water outlet, and T5 exhaust gas inlet, and exhaust gas outlet is T6. This is the, using this we have already seen the formula, there we will be measuring this temperature from here and we will substitute the readings. Then for calculating the volumetric efficiency, we say that using the manometer we will be measuring the readings, then we will calculate the volumetric efficiency V actual and Vs. Then mass flow rate of the fuel, to measure that one we have the burette of the 50 ml content. So in this, when we press this to here, this will be coming to the measuring mode, so the inlet will be stopped in this. So for the 50 ml of measurement, how much time it takes, that we will be measuring using this one. Here we are seeing the control panel, the loading unit for the dynamometer. So by adjusting this, we can vary the load. Initially we keep it in the no load condition, gradually we increase the load to medium load condition, then finally to the full load conditions. Under these different loads, we will measure the different efficiencies. And here we are seeing the rotometer for the engine and rotometer for the calorimeter, which are basically used to measure the flow rate of water in terms of liters per hour, that is the LPH. Rotometer engine, and this one is the rotometer for calorimeter. This is all about today's practical session. That is about the test on various load conditions in the single cylinder diesel engine to measure various efficiencies and also to plot the heat balance sheet. So thank you.